Hello, everybody. Welcome on the Innovation and Strategy blog. I'm Guillaume Villon de Benveniste, your host. And today we're going to talk about biomimicry. And we've got two experts on the matter. Cindy, would you like to introduce yourself?
Hi, I'm Sidney. I'm the founder and CEO of Bioxegy, and I'm one of France's experts in biomimicry.
Hello, my name is Gérard de Bourbon, and I'm involved with an organization called INL, the International Nanotechnology Laboratory. It's an intergovernmental institution based out of Braga, sponsored by the Spanish and Portuguese government. And we work in nanosensors and nanotechnology, and biomimicry is at the forefront of our thought process.
Great. So let's start with a very basic question. For those of us that are not experts, how would you define biomimicry? Sidney, would you like to start?
I would define biomimicry as an R&D approach. It can also be defined as an innovation method, which consists in drawing inspiration from nature's best techniques, principles, and even behaviors sometimes, in order to create new technologies, in order to solve technical issues, in order to innovate in general. Biomimicry is very transversal. It's it is in very different ways. It can touch. It can be in cooling systems, in materials, etc. I'm sure we will get into the details afterwards. But to define biomimicry, I would say it's one of the best options we have out there now to imagine a future which is which can reconcile the notion of technological progress and of sustainability. So to keep it short, I think biomimicry is a very promising innovation approach, and it is, I think, one of the future pillar of human progress.
Cool. That's an interesting and ambitious definition. Gérard, would you like to share your view on the definition of biomimicry?
Well, I would say it, and I wish it was more prevalent, but I will see it as a sort of a template or a mold for innovation. And I mean, if you look at and start really, we all think of the masters of nature and the many years of evolution of what animals and plants and all these organisms have done in the past. They're the teachers, right? So if we actually look at what has been done in the past, we can really learn a lot. So it's basically I will say a template or a methodology to ask ourselves questions, and as I said earlier, to include them in our thought process. It's not the magic bullet for everything, right? Because it's not that easy to go ahead and just say, well, I'm going to do everything that nature does, and by magic things are going to happen, because things are never that simple. But I will say a template that if applied, it will enable a lot of things, as Sidney said, circular economies, a better path for sustainability, and truly contributing to what we're experiencing and combat what we are seeing and what's happening to the world today. I think we've all been living on borrowed wings and consume more than what the world can produce. If you look at what's happening, I mean, it's amazing.
Okay, cool. So basically, two actually very interesting definitions with a lot of things in common. The idea of reconciling sustainability and technological progress, and the idea of a methodology or a template for sort of drafting new approaches to building new products and services. But let's get really short term, if that's okay. We're in the middle of a crisis, as you know, Sidney.
Yes.
How is biomimicry helping us managing the pandemic?
Well, I think there are many aspects that we could talk about, but I would like to give some examples because I think that's the best way to address your question. Is that first of all, biomimicry can develop technologies helping us, tackle some viruses or some dirt on surfaces. So the best example about that is the shark skin technologies, shark-like technologies. I think that Gérard, you know this technology well,
Yeah.
And I think you'll go into the details. But it's a technology that can help clean, surfaces without products, without chemicals. I think it's a very interesting and promising technology that can be used in hospitals and that can help fight some viruses. I'm not sure if the technology is transposable to the coronavirus itself, because there are many types of different viruses. So that's the first I think aspect of how biomimicry can help us fight the coronavirus or any health issue to itself. It's intelligent surfaces and auto cleaning surfaces. I think that's a promising view. But concerning Bioxegy and our work and what we are working on, it's more about how can we efficiently renew and recycle the air inside some spaces. It's one of the big issues with coronavirus right now, is that if you have a closed space, the virus, and if you don't recycle the air, the transmission of the virus is a big issue. And so we have been working with one of France's top transport operators, which includes a lot of underground tunnels and underground spaces. And so initially we were working on particles and air pollution within these underground spaces, but we have been switching on another dimension which is efficiently recycle the air in order to have fresh air and less virus transmission. And our goal is not itself to fight the virus, but recycle the air efficiently. So what does it mean to recycle the air efficiently? It means without using a lot of energy recycling the air, and also without making too much noise, because if you have too much noise, you can create some problems within an area of our neighborhood. So our client operates some big wind tunnels with regular wind turbines, which bring the air inside the tunnels, the metro tunnels. And so we have been studying some marine, I can't go into all the details which are confidential, but we have been studying some marine mammals which have specific way of dealing with the hydro flow, so the flow of water, and which can help us bring up the output of the wind turbines. And so it can help us target our objective is, one, create more recycling, so more flow of air without consuming more energy, which is a big issue. And the second objective, which is create also big flow of air without having too much noise in the immediate neighborhood of this wind turbine, vertical wind turbine. So we are still working on it, but I wanted to give this example because I think this is one of the big advantages of biomimicry itself, is that there are so many scales and so many aspects you can work on, and you see both. One is very direct, is auto cleaning surfaces, and the other one is very indirect, is recycling the air. So
Okay.
yeah, Guillaume, I hope this answers your question.
Yep, perfect. So you mentioned two technologies, recycling the air, and the second one was cleaning surfaces. The first one, actually. Gérard, would you like to go at it?
Yeah, I mean, look, I echo what Sidney said. I mean, nature has been fighting viruses and bacteria for years, right? And if you look at what Sidney mentioned about Charlotte Technologies, there's a company that was founded, I think, in the mid to late 2000s. I mean, basically is mimicking the basking shark skin in how bacteria really has a hard time attaching itself to it. So they build films for surfaces for hospitals, for schools and things like that to sort of combat bacteria. But when it comes to the pandemic, I mean, the virus can attach itself as well to surfaces. So, building, nano structures and in mimicking nature, like the wings of dragonflies and other insects, they have this tiny little pillar structures that make it extremely difficult for bacteria and viruses to land. Then they sort of actually disrupt, so they are unable to attach themselves to it. So in nano coatings is an area that is being used now on face masks and textiles, also mimicking structural natures of nature, right? So I mean, a lot of this stuff is being considered for a slew of surfaces and so on. When it comes to air, I mean, Sidney mentioned the Nautilus effect. As you know, the ventilation, it's important that you have, circulating air and also really high filtration, right? I mean, the virus is tiny. It's only 100 to 120 nanometers. So it's a really, really tiny virus. And the filters that stop that are class 3 HEPA filters. And in order to just install these filters, the ventilation systems of today's homes and buildings are not designed to handle that high pressure air going through. So you need to retweak and reinstall that. And if you use the Nautilus effect to sort of accelerate, air inside of a building, it is, as Sidney said, it's important to circulate that to minimize the number of viral particles that are aerosol in rooms, right? If you have a super spreader in one area of the building, it can create havoc because the viral particles remain airborne for many, many hours. So, and it's all about reducing the number of particles that we inhale that makes a difference, right? This is why masks have a significant impact. And if the masks have, antibacterial nanocoatings or your fabrics and your clothes, I mean, that's even better, right? So I think this is the type of stuff that we're going to see in the new future. Not because of this virus, but I mean, I think hopefully we learned from what's happening with this pandemic. I mean, we've been getting hit every 3 to 5 years. It's not a matter of if, but when we're going to get hit again by a new virus. And we need to be prepared, right? So learning, looking at what nature has done before, it's in our best interest.
Okay, that's actually a great transition to the next topic that we could talk about, which is how does biomimicry help us address longer term challenges? And Sidney, you talked about the fact that one of our challenges was building a sustainable economy. So maybe you can tell us how, and Gérard mentioned that we've been flying on borrowed wings, so to speak. So how can we reconcile our way of life, which is very energy voracious, with perhaps the energy efficiency that you could build with bio-inspired products and services?
I think there are many ways to answer this. I will just, give you my experience of how I live this with my company. So as you know, Bioxegy is a design and engineering office, and our job is to work with the R&D departments of our clients, which are industrial companies in France or in Europe. And so that's how we live, and how we implement biomimicry. So what we have been seeing in the energy sector is very, very, there are many aspects. Sometimes it's about, we have been seeing clients where we have been developing the detection, leak detection technologies. There are some of our clients which operate, big gas pipelines in France, and the problem is that these big pipelines, they leak a very great amount of gas, and this is very hard to tackle. And we have been developing a technology which is very smart, based on an insect that can detect pheromones very far away. So we have, retour engineered the way this insect smells the pheromones in order to create a technology that detects gas leaks, in a very good way. So it helps bring the gas leak under a certain level. So that's, the short term, what we call problem-solving biomimicry, and that's the first, very humble way to bring new ways of thinking in some industries. But what I think is more promising is what we call disruptive biomimicry. So this is harder to implement within a client because let's be real, our clients, and I'm sure we will get into this in a couple of moments, but the clients, they are still, very, they're not sure about biomimicry. They still need to understand how it can help them. So bringing disruptive biomimicry into the business is way more difficult. But what we have been seeing now is that one of our clients is, a landing gear manufacturer. And it's a big shot here in France. And when you see the aircraft industry is under the radar, especially here in France, but I'm sure it's in other countries in Europe, it's the same. Is that we know that the aircraft industry is is at the center of how we can of how we need to change the way we consume, because it has a big impact on the environment and on the global climate change. And so if you see our clients, specific client, is that when considering how we can help our client create landing gears that are more sustainable in some way, it is creating landing gears that are way lighter and way more efficient than the one that they are building right now. So we are on a more disruptive biomimicry scale, because what the work we are doing, the projects we are doing with our clients, how can nature help us design landing gears in 5 or 10 years that are maybe 50% lighter or maybe 75% lighter than the current ones. And so the goal of our biomimicry project right now is to understand how some insects, some plants, or some animals are coping with energy absorption, because landing gear is all about absorbing the energy of the aircraft that is touching down on the runway. So we need to understand how some fibers, some articulations, some bones, some structures in nature, maybe, as I said, in insects, animals, or plants, are coping with energy absorption. And then our engineers need to understand how they can transpose and transfer. This is, mind abstraction. You can't copy straight. You can make an exact copy. It's not possible. So we have to make some transverse thinking. It's very disruptive thinking. So I think that's the way biomimicry can be really, really helpful in tackling this very big issues, this big challenge of sustainable industries. At least that's how we live it at Bioxegy level, at the level of our company. And to sum up, or to add something, is that there are a lot of other, of course, aspects of how biomimicry can be useful. actually in every industry, every sector. We have been seeing lots of projects, but I think that the university level, and maybe Gérard, you can go into details or your opinion on that, but the research level is also very paramount in terms of sustainable biomimicry. But I have been seeing, amazing battery technologies coming from Virginia Tech or Georgia Tech, or some studies here in France about bio-inspired batteries that can that use less metal, that can be recyclable, that are way more efficient. And that's something that is really interesting if you want to electrify vehicles. Some are based on how our internal cells deal with energy. Some are based on how plants deal with energy. There are a lot of different aspects, and I think that one of the most promising ones, but harder to get, is of course how can we mimic the way plants harvest solar energy, artificial photosynthesis. And I think every big and major lab there is out there is working on that, and I have been seeing very promising research here in France or in Europe. So well, to sum up, Guillaume, I think there are a lot of different aspects, and as I said, biomimicry is the best option we have out there to imagine our future.
Mm-hmm. So you talked about an example in the aviation industry, and then you finished with an example on energy absorption through photosynthesis, which is obviously a cross-industry. Gérard, would you like to share your views on the matter?
Yeah, absolutely. Look, and he's spot on, right? I think, Sidney, you're 100% correct. I mean, and I said earlier that yes, we're living in borrowed wings, and we've abused Mother Earth with a complete and total disregard. And I think industry and society need to start thinking about planet, people, purpose, and profit. If you do things in that specific order, you're always going to be profitable, because companies that think and act that way, they're always coming ahead. When it comes to circular economies, I mean, there have been many companies that have been remanufacturing things for a long time, some of them 30, 40 years, and they really don't advertise that, right? Because they feel, well, it's a stigma if I'm remanufacturing engines for trucks. But some of these people are sitting on a lot of data that can be reused by other companies to learn how to remanufacture and repurpose these different widgets they make that are better for the environment. When it comes to energy and in biomimicry and in the topic that Sidney was discussing, that's extremely interesting, in my opinion, is batteries, right? The enemy of batteries are dendrites, and dendrites form in a battery, and that's the battery killer, right? So what we're looking at is sort of looking at how cells, when cells in bacteria, certain bacteria, when they're dying, they produce what is called necrosignals, meaning that they send a warning out there that they're being attacked by something. It could be a virus, could be something else, or antibiotics in this case. And they produce these necrosignals, so the more bacteria get formed, right? So the whole idea is how to reverse that, to understand how dendrites form in batteries, to sort of mitigate that, right? And the whole idea of that is you want to be able to enable a circular economy in a secondary market. I mean, there's still a big problem right now with batteries, because if you look at secondary markets for electric cars are bad, right? Teslas have a really poor secondary value. And the reason is people are afraid of buying an electric car because they don't know how it's been used, how it's been charged. You know, if it's been used as a fast charge or a slow charger, and a fast charger normally kills the battery a lot quicker. How you've been driving the car. So it has nothing to do with kilometers. It's really the usage that needs to be monitored. So if you look at nature and how nature is using energy in a more efficient way, that applies to also electric vehicles in storage of energy. In surfaces, in different types of materials, I think in the future, and it's already been worked on with different entities, You will not see batteries in the car, but the entire structure of the car will be the battery, right?
Mm.
With graphene enabled type structures, right? And again, you're looking at nature to do that, right? To be the master, the teacher of how the structures are formed, how the shapes are that are more rigid in wafers and in shapes to make the rigidity of the car more sound. So looking at patterns and so on. So this is just there's a slew of things coming out that make a huge difference. I will envision that in the future, the cars will probably be whatever color you want according to your mood with photovoltaics, and you can change the shape and the coloring of your car with an app and say, well, now I want my car to be orange or yellow today, and just change the paint. But the paint job will be translucent.
Hmm.
So,
and that gets us to another topic,
yep.
which is the difference between dream and reality. Obviously, biomimicry, as you know, has been around for at least, I know that it's been around at the end of the 19th century. I'm sure that someone like Da Vinci would study animals and plants to develop a lot of his inventions. So as experts in the field, what's the state of biomimicry today, and where would you draw the line between dream and reality? Sidney, do you want to take a go?
Yeah. Look, I want to be real with you, Guillaume. The reason why I have founded Bioxegy is because I have, at least in France, observed that there was no real connection between the university level and the market. In short, French companies weren't using biomimicry as an innovation and R&D tool. So it broke my heart because I was passionate about biomimicry. So I thought about it, and I thought, well, why isn't biomimicry with this big promise? I mean, the philosophy behind biomimicry is so evident. Why isn't it more, used within the companies, within the industrial sectors? And from what I saw in France, but I'm sure there are, the issues are the same in other countries. I observed the same dynamics in the Netherlands or in Germany, for example. Biomimicry has, for a long time, has been, the monopoly of, of research, of biologists. And it's a good thing because they are needed. But the problem is that if you want to create a transition, an efficient transition with the companies, you need to have more people and a diversity of talents that can bring result-oriented projects. I want to be really clear about that, is that biomimicry is still in the initial phase. So from what we have observed in France is that you can't push the client, you can't push a big industrial client into doing biomimicry at the very ambitious scale at the beginning. It's not possible. You can't bring them to do that. You can't bring them to spend €500,000 or even €1 million or even more into biomimicry at the start, because they're not sure about biomimicry and they're not sure about nature. Let's be real. It's a very disruptive way of thinking. So what we have been doing in order to tackle this, in order to be in the real world and not in the dream, is that we have been, really directive with our clients. I'm just talking about our experience, but we have been very clear about that and pragmatic, and we have been thinking, okay, our clients have a big scale and range of products. So we need, as a company, as a biomimicry expert, we need to target really specific topics where we are sure to make quick wins. And when I say quick wins, is within 6 months or within 2 years. That's our job. And if needed, if we have been having some relations over 2 years, over 3 years with our clients and having quick wins, some good projects, then we can, pass on to another scale of biomimicry and be more ambitious with our clients in order to have longer term projects. And it works like this. With I take one example, is when one of our clients, it's in the construction business. The construction business doesn't have, in France at least, a lot of innovation power, because they are not making big benefits. So they're not sure about making big innovation. So at first, with one of our clients, we tackle very humble and very specific projects within the buildings that they were creating, and it worked fine. And once we had their trust, once we gained their trust, they became more ambitious, and we became more ambitious, and we tried to target biomimicry projects that were more long term. And we succeeded in doing that, and we succeeded in convincing them to invest way more in order to create a project that we are doing right now. We launched it a couple of months ago with the big CNRS, which is the big French research facility. And it's a long-term project, and it's a big investment for our clients, and that's how I think it should work. And to sum up, I think we as a community in biomimicry, we need to be pragmatic. We need to be result oriented. We need to quit the philosophy level and be more in the project and direct project level. And we need to do this. And I think it is not done in a good way. I see some associations. I see some people that are doing conferences and speeches, and that they're writing books, etc. Okay, it's fine, but we need projects right now. So I think, I hope this answers your question, Guillaume. I think we need to put everything we got into short-term projects with industrial. That's how we are making proof that biomimicry is working.
Okay, so a plea to be pragmatic.
Yes, exactly.
Gérard, would you like to share your views?
Spot on. And this is what I said earlier, that biomimicry is not a magic bullet, right? And you see that with circular economies, right? People go out there and they have a great idea of, circular economies, of how to make their business more environmentally friendly. And then they go to their board of directors or the CEOs, and basically it's like, oh, I have this really cool project. And is it going to be profitable? No. But it's great for our environment or CSR. Is it profitable, right? And that's really where I think you're spot on, that we need short-term wins, and we need examples that can be materialized. Otherwise, at board level, you're not going to get the attention. And this is what we've been working really hard in INL, is to have a middle of the ground approach with this interdisciplinary, middle ground between the R&D, the scientists that are a little bit very long-term thinking, and the people in the engineer and the business side that are thinking, well, what does the business need? And because even though I said we should be thinking planet, people, purpose, and profit, the reality is that the boards of directors want profits, right? That's what the companies are designed to do. So they are looking at putting profits first. So you need to be cognizant of that approach and understand that the value that you need to bring to highlight biomimicry needs to be on the business side with quick wins, really good examples of integrated, from our cases, integrated devices. They can really take a lot of the best things of what nature is doing and bring them to light. And right now, it's a fantastic time, because if you look at 5G coming around the corner, and what that's going to do for narrowband IoT and connecting all these sensors that have been done from a molecular scale and upwards, in the past, they haven't been connected as much. because for a telco, the cost of provisioning a SIM or a number is quite expensive. It could be about 15 euros per device, right? But with narrowband IoT and 5G, you're going to have that cost drop down significantly, thus enabling all this interdisciplinary connectivity of devices for many, many sectors, for healthcare, for industry, for whatever, right? And all these nano devices will be connected. I think that's going to create an explosion of projects that are going to be profit-minded, but it will enable these quick wins that we've been looking at. So I'm really optimistic about biomimicry. I'm really optimistic about nano IoT connectivity and applications development, and the platforms that will support that single version of the truth to work on this outcome-based business models that will give the results that are needed, so that the guys at board level say, you know what, this biomimicry stuff is actually pretty good and I want to put more money behind it.
So basically,
it doesn't work.
So biomimicry produces results, which produce interest and profits, and that helps distinguish dream from reality.
Precisely.
So this is pretty much, yes, go ahead.
I wanted to give one example. I think that is really, that illustrates how biomimicry can be misused. I've heard of a story in France with a sport manufacturer, so sport good manufacturer, and they wanted to tackle they wanted to create a ball where the level of how the hand, how do you say that in English, adhérer, adhere, yes. So how the ball can fit into your hand in a better way. They wanted to find something, and so what they did is that they partnered up with an association here in France, which says that it is experts of biomimicry, and what they suggested to the sport manufacturer was to take example from the gecko hand, the gecko foot. The gecko foot, of course, the lizard foot is adhering really well to surfaces. That's a well-known example with biomimicry. Yeah. But I think it happens on the nanoscale. So how would you imagine transposing something that is happening on the nanoscales with Van der Waals phenomenon, which is on very small scale? How do you want to transpose it to handball, to the sports ball that needs to be produced within 10 or 15 euros range? That's not possible. So I think that is a really a miscarriage of biomimicry, and that shows how you can disappoint a client. And I can assure you that this sports manufacturer is not ready and will not be ready within 2 years of doing biomimicry again, because they have been disappointed, and then they have invested money in that. So I think that's a good example of how biomimicry can be misused.
Okay. All right. Well, those are our last words. Thank you very much, Sidney, for coming on. Gérard, thank you very much also for suggesting that we discuss this matter, because it was initially your idea.
Thank you.
And it was great to have you, and have a great day, and let's talk soon.
Thank you very much. Thank you, Sidney.